Now let's take a look at the fundamental one. An example. The question is for you to calculate the internal loadings at point C in the beam. This is your beam. Here you can see from the diagram, you have 60 kN meter applied moment and also 10 kN point load. They ask you to calculate the internal loadings at point C. This is your point C. The procedure of calculation. First, you need to draw the free body diagram and show all the support reaction. Reaction or reactions depend on the support that you have. Second, by using equilibrium equation, you need to calculate the support reaction. And then you already calculate the support reaction. Then draw again the free body diagram for internal loadings. By following the follow the sign convention. Remember the sign convention. If you take from left, if you start from left, then your sign convention will be N to the right, V downwards, and moment is counterclockwise. But if you take from right, then your N will be to the left, V upwards, and also moment clockwise. So please remember this sign convention. And then again, by using equilibrium equation, calculate the internal forces. This is the procedure that you need to follow. First is to draw the free body diagram for support reactions, and then by using equilibrium equation, you need to calculate the support reactions value, and then draw again the free body diagram for the internal resultant loadings that the question asks you to by following the sign convention. And after that, by using equilibrium equation, then you need to calculate the internal forces value. From this question, at A, the support is roller. At B, the support is pin. You know that roller you have one support reactions. I note it as a AY, and B, I label it as a BY and BX. How about the direction of the support reactions? I assume. And then you draw the free body diagram. kN meter applied moment, and then AY support, BY and BX, as well as 10 kN point load. The direction is 2 meter. 2 meter. Ignore the point C because we need to determine the support reaction first. And then second step is by using the equilibrium equation, you need to determine the support reaction. From the free body diagram, you can see that you have 3 unknown, which is AY, BY and also BX. If you have 3 unknown, then you need to use 3 equilibrium equation. If you have 2 unknown, then you need to use 2 equilibrium equation, and if you have only 1 unknown, you need to use only 1 equilibrium equation. So always start with summation moment because you want to cut down the unknown. Summation moment is equal to 0. We take moment at B. Okay, summation moment at B is equal to 0. My definition is clockwise positive. If you are familiar with counterclockwise is positive, then you can use. Remember, moment is equal to force times distance, perpendicular distance. Okay, so let's start with the calculation. Summation moment at B is equal to 0. Clockwise is positive. Then I start from here. Okay, you need to step by step so that you did not miss any forces. 60 kilonewton rotates towards B, so it is negative 60, and then AY rotate towards B. AY is a force plus AY, the perpendicular distance is 2, and then plus 10 rotates towards B, then the distance is 2 is equal to 0, and then AY is equal to 20 kilonewton. In my class, I always teach students to put the annotation at the top of the calculation so that you did not miss the distance. This is a simple calculation or simply supported beam, but if you have a very complex beam, then you will miss one of the distance. So you put this one, this is moment, so no need to times distance because it is a moment. As I mentioned here, force moment is equal to force times distance. This is your force and this is the distance. This is your force and this is your distance. So your calculation is correct. After you get the AY value, then another equilibrium equation is summation Fy. Summation if Fy is equal to 0, my definition is upwards positive. Do we need to take 60 kilonewton? No. Why? Because the unit for force is Newton or kilonewton. The unit for moment is Newton meter or kilonewton meter because force is kilonewton, distance is meter. You just take the Newton or kilonewton for unit. Start with AY. We already get the AY value, which is 20 plus, because it is upwards, BY, and then minus 10 kilonewton because it is downwards, is equal to 0. Then you get BY is equal to negative 10 kilonewton. If it is negative, means that it is opposite direction as you assume. So the actual direction for BY is downwards. And then another equilibrium equation is summation Fx is equal to 0. To the right is positive. Then Bx is equal to 0 because there is no applied force in X axis. You already get the support reaction value, and then we proceed with internal resultant loadings. If you look at the question asks you to calculate the internal loadings at point C. Now we cut here. Okay, we cut at this point, so it's up to you. You would like to start from here, or you would like to start from here. Both will give you the same answer. So now you calculate the internal resultant loading. So draw again the free body diagrams. Put the value. AY is 20 kilonewton. BY should be downwards, which is 10 kilonewton. And the applied load is 10 kilonewton. This is your point C. You need to cut at point C. If I start from the left, then I have 60 kilonewton meter, 20 kilonewton, and also the internal forces. This is point C, NC, VC, and also a moment. If you take from right, then you will have this value of 10 kilonewton applied load, 10 kilonewton for support reaction, and the point C, NC, VC, and also a moment. By using equilibrium equation, then you solve this equation. Summation moment at C is equal to 0. Clockwise is positive. Why I take moment at C? Because C, at point C, you have more than one unknown. Negative 60 plus 20 times 1, the distance, minus MC is equal to 0. Then MC is equal to negative 40 kilonewton meter. For internal resultant loadings, it have its own sign convention. Then if you get negative value, just leave it as a negative, because we follow the sign convention. And then summation Fy is equal to 0, upwards is positive. You have 20 minus VC is equal to 0, then VC is equal to 20 kilonewton. Summation Fx is equal to 0, then you know that NC is equal to 0. This is your answer. This one also is your answer. I chose the calculation is from left, so I will erase this one. But if you would like to do the calculation from your right, it's okay. You will still get the same answer. Now let's move to the next example, which is the linear distributed load. Determine the resultant internal loadings acting on the cross section at C of the beam. If you can see from the figure, you have fixed supported, this is fixed, and you need to calculate the internal resultant loadings at point C. Okay, this is a linear distributed load. For linear distributed load, you need to convert the magnitude into forces. You know that unit for force is kilonewton or newton. The magnitude, this is a magnitude. Magnitude, the unit is newton over meter or kilonewton over meter. How to convert magnitude to force? You need to times the distance, because you want to cancel out times distance. Distance is meter, so when you time distance, you can cancel out meter here, then you will get newton. Newton is a force. Okay, that is how you solve the linear distributed load or uniform distributed load. You need to times the magnitude with the distance, because we would like to cancel out the meter, and then you will get the force value. So refer back to the first procedure. You need to draw the free body diagram. We draw the free body diagrams for linear distributed load. The maximum magnitude is 270 Newton. At B is 0. At A is fixed. Fixed you have, and also a moment. This is your free body diagram. The distance is 9 meter. Now use equilibrium equation to solve the support reaction. Summation moment at A is equal to 0. Clockwise is positive. Why I take moment at A? Because more than one unknown. So remember how to solve the linear distributed load. You need to calculate the area under the graph. 1/2 times the magnitude 270 times the distance is 9. This one will be your force. You know that moment is equal to force times distance, and the distance is 1/3 times 9. This is your distance, and then this is for triangle, plus MA is equal to 0. MA is equal to negative 3645 Newton meter. Why 1/3? 1/3 here because of the centroid of triangle. If your triangle like this will be your centroid. If you take moment here and it will rotate here, this one, the distance will be 1/3. If you take moment at here and then the rotation with towards this one 2/3, the distance. Now you take moment at A, it goes like this, so that's why the distance is 1/3. Okay, same goes if you have this type of triangle. This is a centroid. If it's rotate here, this is 1/3. If it go towards here, this is 2/3 the distance. Now you do for summation Fy is equal to 0. Upwards is positive. Then you have negative 1/2 times 270 times 9 plus AY is equal to 0. AY is equal to 1215 Newton. And the last one is summation Fx is equal to 0. To the right is positive, then Ax is equal to 0. Now we will calculate the internal forces at C. First, you have to draw the free body diagrams. Choose the simplest shape. This is your C. You can start from A or you can start from B. It depends which one is the easiest one. If you start from A, you will have a trapezoid shape. If you have trapezoid shape, then you need to divide it into two shapes, triangle and also rectangular. If you start from B, then you have a simple triangle shape. I would like to start from B because I will have a simple diagram. This is point B, this is point C. When you cut here, you will expose the internal forces NC to the left, VC upwards, and also a moment clockwise. This one I follow the sign convention. If you look at again the figure here, you only have the maximum magnitude, which is 270, and minimum magnitude, which is 0. How about the magnitude here? So you need to do the ratio. Now we would like to find what is the magnitude here. Then you do the ratio between big triangle to small triangle. In the big triangle, you have the maximum magnitude, which is 270 with the distance of 9. But this one, your distance is 6 meter. For ratio to small triangle, which is the magnitude that we would like to calculate, I name it as a W, and the distance is 6. Now you manipulate it, then you will get that the W is equal to 180 Newton per meter. So this one, W is equal to 180 Newton per meter. Now again, by using equilibrium equation, you can solve this one. I will give you the answer. You do the rest of the calculation, same like this one. MC is equal to negative 1080 Newton meter. BC is equal to 540 Newton, and NC is equal to 0. Please do the calculation. And check your answer with my answer. Now we go to the fundamental 3, which is you have the uniform distributed load 20 kN per meter. Same, you need to times the distance. Here A is a roller and B is a pin. You do the calculation AY, and then you will get the answer is 50 kilonewton. And then BY, when you calculate, it is downward, is equal to 10 kilonewton. BX is equal to 0. Please do the calculation and remember back how did you do the calculation for uniform distributed load. Okay, the question asks you to find the internal forces at point C. You can choose if you would like to start from here or you would like to start from B. But if you look at the diagram, if I start from B, it's more easier because I only have 10 kilonewton here. But if I start from here, then I have UDL and also I have 50 kilonewton, which is more difficult compared to this part. This one I start from B. This is your B, and you have point load, which is 10 kilonewton downwards. This is point C. When you have C, When you cut at C, you will expose the internal forces NC, VC and also MC. Okay, and then when you calculate by using equilibrium equation, you will get MC is equal to negative 20 kilonewton meter, VC is equal to 10 kilonewton, and NC is equal to 0. Please check your answer for this one. Okay, please try this example. And also this example. By that, thank you class. We already finished the first part of chapter 1.